Okay, we're going to continue with where we left off in part 1 of this lesson. We were finding roots of negative numbers, and we were simplifying our negative our, our roots of negative numbers. So we're going to start by looking at a problem where we're squaring. And let's say we want to square negative 1 plus the square root of negative 5. Now, one of the things that we mentioned in the previous lesson is you never do any operations while you have a negative number under the radical. You will always take care of that first. So this is going to be negative 1 plus the negative comes out of the radical as I, square roots of 5. We weren't able to take the square root of 5, but the square root of the negative 1 was I. And now we want to square this. Now, there's two ways you can go about doing this. Some of you have learned a pattern for squaring a binomial, which is a plus b squared is the first term squared. Then it's twice the product of the two terms. Well, that's a positive ab, so twice that would be 2ab plus the last term squared, which would be b squared. Some of you may have learned to just write them out as what we mean by squaring, multiplying it by itself, and then using your distributive property, that would be a squared plus ab plus ab plus b squared, which is what gives us that product of a squared plus 2ab plus b squared. So what I would say on these is do whichever one is you're more comfortable with. And sometimes you may be comfortable with using the pattern on some types of binomials and maybe not on your complex numbers. So you do whatever you're comfortable with. And I'm going to go through and show it both ways. If we start out by using the pattern for squaring a binomial, we're going to square the first term. Well, negative 1 squared is 1. Then we want twice the product of the two terms. Well, the product of the terms are negative 1i square root of 5. So we want twice that. So we would want negative 2i square root of 5. Then it's always a plus for the last term. The last term squared, we're going to have to square each one of these. So I squared. And then the square root of 5 squared, well, whenever you square a radical, you get the number underneath the radical. So that would be 5. So we would end up with 5i squared. So we would have 1 minus 2i square roots of 5. The I squared's negative 1 times 5 is negative 5. Then combining our real numbers, we would end up with negative 4 minus 2i square root of 5. Okay, so that's not written real clearly, but negative 4 minus 2i square root of 5. Now, as I said, sometimes when you start getting into dealing with radicals and with your imaginary numbers, you may not be as comfortable using the pattern. If not, then just go back. Negative 1 plus I square root of 5. And then to square it means to multiply it by itself. So negative 1 plus I square root of 5. And then use our distributive property. So negative 1 times negative 1 is 1. Then we would have negative I square root of 5. Multiplying each one by I square root of 5 would have negative I square root of 5. And then for the last term, we're going to have I squared. And the square root of 5 times the square root of 5 is 5. So we have 5i squared. And we know that this is going to be a real number because of the I squared, so we could think about this. This is going to be a negative 1 times 5, so this is going to be a negative 5. So 1 minus 5 is negative 4 minus 2i square roots of 5. All right, let's go through and do another one like that, just to make sure that we are comfortable with it. Let's say we have negative 2 plus the square root of negative 3 squared. Okay, again, we can't do anything with the negative under there, so this is negative 2 plus I square roots of 3 squared. You have to take the negative out first. Okay, if we use our pattern, then we're going to add the first term squared, so negative 2 squared is 4. Then it's going to be twice the product. Well, the product is negative 2i square root of 3, so twice that, twice 2 is 4, so negative 4i square roots of 3. Then for the last term, I squared, and the square root of 3 squared is 3, so we're going to have 3i squared. Well, I squared is negative 1 times 3, so what that does is it makes this last term negative 3. So 4 minus 3 would be 1 minus 4i square root of 3. If you're not comfortable with doing that, then you'd go through and you'd write it down. Negative 2 plus I square root of 3 times negative 2 plus I square root of 3. And do your multiplication. So negative 2 times negative 2 is 4. Negative 2 times I would be negative 2i square root of 3. I square root of 3 times negative 2 is negative 2i square root of 3 plus I squared, and square root of 3 times the square root of 3 is 3. So 3i squared. Again, I squared is negative 1 times 3 is going to make that a negative 3. So 4 minus 3 is 1 minus 4i square roots of 3. But we go through and we can do our multiplication. Uh, and then if we wanted to look at a little division, and this is just going to be division by a real number. We've already looked at dividing by conjugates, but we're simplifying. If we have the square root, if we have negative 14 plus the square root of negative 12 divided by 2. Okay, we can't do anything as long as we have a negative under the radical. So the negative is going to come out as I. Let's just go off to the side and do the square root of negative 12. Okay, that's the square root of negative 1. 12 is 2 times 6, and 6 is 2 times 3. Okay, the negative, and you can remember it this way, the negative is always going to come out of the radical as I, square root of negative 1. Then the square root of 2 times 2 is 2 times the square root of 3. So this is going to end up being 2i square roots of 3 over 2. Now if you remember, we can break this up into two parts. So we have negative 14 divided by 2 is negative 7, and 2 divided by 2 is 1. So we would have negative 7 plus I square roots of 3. They may not always turn out where they will divide it exactly. Let's say that we have negative 15 minus the square root of negative 18 divided by 33. Well, that gives us negative 15. Now, we have to deal with the square root of negative 18. That's the square root of negative 1. 18 is 2 times 9. 9's 3 times 3. So the square root of negative 1 would be I. The square root of 3 times 3 is 3. And then we have left a 2. So it would be 3i square roots of 2 all over 33. Now, if we're wanting to leave this written as one term, or as one form uh, with the numerator and denominator, then what we would look at is what we could divide 15, 3, and 33 by. And we can divide all of those by 3. So we could reduce this and have this as negative 5 minus I square roots of 2 over 11, where we divided each one. Or we could break it into two parts and have it as negative 15 over 33 minus 3i square roots of 2 over 33. And then reduce each fraction. So again, these are both divisible by 3, which would give us negative 5/11 minus I square root of 2/11. And doing it this way, it might be that you don't always have the same denominator because they might could reduce in a little different form. Okay, we're going to look at one last problem that's going to deal with evaluating an expression. If we had the expression x squared minus 2x plus 5, and we wanted to evaluate it for x is equal to 1 minus 2i. Then we're going to substitute in. So 1 minus 2i squared minus 2 times 1 minus 2i plus 5. We simply do our operations. Okay, we're going to square the binomial. We just did that in a problem. You can either write it down twice, whichever way you're comfortable with, or you can use the pattern. I'm going to use the pattern right now. 1 squared is 1. Then twice the product would be minus 4i plus the last term squared with 2 squared is 4i squared, so 4i squared. Now that I squared is going to make that a negative 1, so it's going to make that a positive 4. I'll get back to that in just a second. Let's go ahead and do the rest of our multiplication. So that would be minus 2 plus 4i plus 5. Okay, as I said, this is negative 1 times 4, so that's going to make this term actually a negative 4. So we have 1 minus 4 is negative 3, minus 2 would be negative 5, plus 5 would be 0. So all of our numbers end up canceling out. Then we have a negative 4i plus 4i, which would be 0. Let me check one thing. Okay, I've got a mistake here, and I left off. No, I don't have a mistake here. I've got that correct. And so we end up with 0 for our answer. Okay. So this is working then with our imaginary numbers. We looked at adding, subtracting, multiplying, and dividing. We looked at simplifying our radical forms and how we go about writing a complex number. We'll use this in the next section as we begin solving our quadratic equations.